All right, here's a follow-up video to the beginning of 2.2. We're going to talk about the normal curve a lot more, and we're going to start by defining the empirical rule. So we can find proportions for any interval of standard deviations on the bell curve, but there are three specific intervals that are handy to know to memorize. And let's draw another bell curve. Let's draw the mean. This is just a general one, not specific to a data set. That's one standard deviation. That's 2 and 3. And let's go 1 below. 2 below, and 3 below. And we know that approximately, this is the empirical rule, 68% is within one standard deviation. 68% of the distribution. So that means if I was to shade this area, do some calculus and find the area under that curve, I would get about 0.68 out of the whole. 68% out of 100%. We know that approximately 95% is within 2 standard deviations. So once again, if I was to shade all of this area here, that's almost the entire distribution. That's 95% of the whole. And then lastly, approximately 99.7% is within 3 standard deviations. So, and then likewise, you would shade between the -3 and the +3. But we can you can just label this if you want. You could say something like here to here is 68%. Here to here is 95, and here to here is 99.7. So what we're about to do is we're about to apply this to those Iowa test scores that we started with on the last video. So if you need to pull up that document, it's 2.2. You could look at that, or look at the picture that you already drew at the end of the last video's notes. I have it drawn right down here, and we can refer to that. Let me move my arrow there. Okay. So in that first question, now I'm going to be using that empirical rule that I just wrote. In that first question, I'm really asking, what is the proportion of scores smaller than 374? So if you want to write that down, that's the way I write proportion of scores smaller than 374. So that looks like that's at the second standard deviation below. That refers to 0.95. And it's shading to the left, not within. So remember, the whole curve is 1. What if we take away the middle area, which is 95, and now we have the 2 tails? I'll shade in just a minute. Right now, if all we do is that, we have the area to the left of 374 and the area to the right of 994. So let's chop that in half And now we have this area. If I don't divide by 2, I have this area. Because this purple area is 95, right? Purple plus the green is 1. So it's just a trick with numbers and geometry, and it's symmetric. And I only want that left green shaded area. So I take the purple away from 1, divide the leftover in half, and I'm left with that. All right, let's try some more. So I want to find the proportion of scores. I know it says percent, but proportion is fine also. I mean, up here I guess I should write 2.5%. Don't let that be the confusing thing. I start out with proportions. So we're going to go 529 up to 994. This one is actually more difficult. So if you want to let me ramble on and then come back to this one, maybe it'll make more sense. Actually, you know what? I'm just going to hold for a minute on that one. Let's do a nice one. Let's do this one. 529 to 839. So it looks like 529 is 1 below and 839 is 1 above. So that one's easy, right? That's approximately 68. And then the question that I skipped right above it and the question right below it have an equals. So proportion of x's equal to 529. And then right below the one I answered, 529 less than or equal to x. So I like to think of it as geometry. The definition of a line, of a point, is that it has no width at all. And I'm finding area. Yes, there is a chance that someone scored 529. But in terms of area, 0. Now, I could answer this. I could manipulate it so that the math works. I could ask something like 528 to 530, and that's not 0. But we haven't gotten that far yet. Like what I'm going to show you at the end of the video or on the next video, we could do that. Right now we can't do that because that's not at a 1 standard deviation. So just know if there's an equals, there's no value. So that means the one below 68 there, the or equals, is still 68. It's like an insignificant amount of data. There's just nothing there. But I can do less than 529. So I'm looking at 1 standard deviation below and down. So take away the middle. I'll shade it in a second. That gives me to the left of 529 and to the right of 839. So chop it in half and I get 16. Let me shade it. Maybe that'll help. So I want this. I know this is 68. The purple is 68. If I take the purple away from 1, I now have the green to the left and to the right. So I got to chop that green area in half so that I'm left with that, which is 16. All right, one more easy one, and then we'll tackle the hard one up there that I moved from. So I want smaller than 374. Whoops, let's get rid of all the shading. Smaller than 374, larger than 994. That's outside of 2 standard deviations. So I believe that is just 1 minus the 2 standard deviation rule. So let me shade it. I want this area or this area, and in stats and probability, we read or is like an and, or is like a plus. And I know the purple is 95%. So take 95 away from 1, and we have the green. All right, let's tackle the hard one. I don't know why I listed that second. Between 529 and 994. I'm going to shade this one before we start because it's challenging. So I want the purple and I want the blue. And now that I've shaded it, maybe it's easy. So that means I want 68 divided by 2. And I want 95 divided by 2. And I get 815. All right, hope that makes sense. We have more to do because now we got to jump to the calculator or a table. So, see you in the next one.